So, hello everyone, this is Akshay here, and welcome to our GFG POTD streak of day 109. So, before starting the question, if you're new to this channel, please like, share, and subscribe so that we can learn, grow, and maintain our streak together. So, let's not waste the time further and directly jump to our question. The question name is the length of the longest sub array with the positive product. It's a medium category question. So, let's see what the question says and what are all the approaches we can think of to solve this question. So, given an array ARR consisting of n integers, find the length of the longest subarray with the positive non-zero product. That is, in our subarray the zero should not be there, right? Then only we can say, and only the positive numbers as well as the even number of negative numbers should be there. Then only the it will make sure that the positive product will happen. So for array 0 1 -2 -3 and -4, the output is given as 3, and the explanation that they gave is the longest subarray with the positive product should be 1 and -2 and -3. Okay, so as I said, the positive product is only possible if there are the positive elements or the negative elements are in present in the even numbers. So 2 and 3, the number of elements which are negative is 2. So therefore, the longest required length is given as 3. Similarly, if you look at the example number 2, then for this given array, they are saying as the output is 2, and they have considered the two possibilities, that is the -1 and -2. It will give the positive number and the length is 2. Similarly, in 1 comma 2, it will give two positive numbers, the product will be positive, and both have the length equals to 2. So they have considered the length as 2 for this test case. Okay, so the constraint is 10 power 5, and let's do not think in respect to the constraint now. So this question, like this type of question and always occurs on my GFG POTD playlist. So we have to find the all the possible sub arrays, and then you just have to make some conditions, right? And then we'll be good to go. But finding all the possible sub arrays will be taking O of n square, right? So I would like encourage you to pause this video now and think and code and try to code yourself in a O of n square solution, a very naive approach where you will consider all the possible subarrays, and in the nested for loop we'll just mention this condition that I want the positive non-zero product, and you will maintain an answer to store the maximum length of the subarray. So highly encourage you to pause this video now and write the code yourself for the naive approach, and we will then think of the optimization, right? So okay. So if you are able to write this O of n square solution, then it was well and good. You are on a good track, I guess. So now let's discuss about the constraint. So constraint was 10 power 5. So the maximum time complexity, if you look at my chart, 10 power 5 is n root n, right? Because this is the very close bound to 10 power 8. So it should be less than 10 power 8. That is why the maximum time complexity can use it n root n, and below you can use anything to get your code submitted in this following approach. So if you're not able to understand this 10 power 8 logic, I have made this video on time complexity video. It must be flashing up here. You must watch that video, right? So if you're able to write this nested for loop conditions, so it was well and good, but okay, we will see then how this code is running. So for this elements, the elements were given as 0, minus 0, 1, -2, -3, and -4, right? The possible subarrays could be formed like this. When we start with 0th element, the subarrays will be 0 1, then 0 1 -2, 0 1 -2 -3, and then 0 1 -2 -3 -4. So I have made these lines here, as you can see. Similarly for 1 and -2, I have done this, and I have calculated the product as well. So if the current element is starting at 0, it would be 0, right? And I do not have to consider that that possible subarray in my answer. So here goes our two for loop, the two nested for loop, which will consider all the possible subarrays. And here goes our the statement where it says that if array is array of 5, the starting point of the possible subarray is 0, then you do not have to check further. That is continue from there. And I have initialized a variable, let's say prod equals to 1. And for the rest of the possible subarrays, I have actually multiplied those elements using this prod star equals to array of j. This is nothing but I have written it as prod is equals to prod star array of j. This is just a shorthand operator to write like this. And if the product is greater than 0, then include that possible subarray length into an answer. And how do I calculated the possible subarray length as j minus I plus 1? So let's say you have this elements 0 plus 1 minus 2 minus 3 4, and their ith pointer at this point and the jth pointer at this point, right? And the product is employing 2 for this case, for this possible subarray is 6, right? And you need to find the length as 3. You can see the length is 3, but how to tell that code? Tell it to the code. So if I do j minus I, the indexes here at 0 1 2 3 4, j minus I, then it will give us 3 minus 1, that is 2. right? But actually the number of elements in the I to jth range is 3. So I will do 2 plus 1. So in generic, I can say that the possible sub-array length would be j minus I plus 1. And that is what I have maintained the max for the this answer variable. Answer is equals to max of answer comma j minus I plus 1. So I hope you are getting this point. This was a very naive approach, and this always comes whenever there is and this always works whenever there is a question of possible sub-arrays. You just run the two nested loop. You initialize the possible conditions as asked in the question, and you're good to go, right? But this code is taking O of n square, right? So even if I code the solution, some of the test cases will pass, and we will get a TLE, because n square is nothing but the 10 power 5 whole square, which is 10 power 10, which is greater than 10 power 8, and we will get the TLE. So we are not afraid of TLE. We just have to verify that it is actually getting a TLE or not. We just have to uh, make a concept strong. So I will write this code in the compiler now, and we'll see for ourselves, right? So I am pausing this video now so that we cannot make this video longer. Okay, so to avoid making the video unnecessarily longer, so I have pasted the code here, and let's hit the compile and run button. It's the same code I just explained you in my dry run, right? Okay. So as you can see, your output and expected output matches. But if I hit the submit button, surely more than maybe 50% of cases will run, because that will not hit the bound of 10 per 8. And for the rest of the cases, it will give us the TLE. So as we can see, more than the 1,000 cases have run successfully. But yes, we are waiting for TLE, and that's great. So we got the TLE at for the cases beyond 1,000, right? So it must be hitting the bar of 10 per 8. That's why it's happening. So what should be the optimization for this thing? How should we optimize this code? So the optimization can be done. So I highly recommend you to pause this video now and think for the optimization. Then only, like, it would be a good practice for you as well as for me to simultaneously learn and grow, right? So think of the optimization and then get back to this video, right? Okay, so let us resume. So the method 2 will be like responsible for it can the intuition would be like to maintain three possible variables. Like one is the possible variable, a positive variable, which is nothing but signifies it actually signifies the storage. It stores the length of the current sub array with the positive product. Similarly, the negative, it stores the length of the current subarray with the negative product. And in the result asked by the question, we need the store the length of the longest subarray with the positive product. So that means if you do a traversal for I equals to 0 to I less than n, I plus plus. So when you are at this position, let's say I equals to 3, right? So for 0 to 3, you need to have these variables positive. So into 0 to 3 array, what is the length of the maximum what is the length of the maximum possible sub array which is having the possible length, right? So if I give you one example, so this is, let's say, 1 and minus 2, right? So this is the elements belonging to, let's say, 0 to index 1, right? And what I need, the positive here will be belonging to just 1, because there is just one. It is, you can take just this element 1, which will lead to the positive product, right? And in the negative thing, you can take the both elements, because the product will be minus 2, right? So in the negative, you will say, you can see that the length of the current sub array with the negative product will be 2. So now try thinking in this direction, and try writing the efficient code for yourself. And if not, then we will just resume the video again. But try for some time, and I think you will be surely getting the answer. Okay, so let us continue. So what I'm doing is that I'm traversing for each and every ith index here, right? And I'm just maintaining three variables, that is positive, which is implying for the length of the current subarray with the positive product, and the negative product as in the negative variable, and the result for the longest subarray with the positive product, right? So for I equals to 0, 1, 2, 3, 4, I have made uh, three columns here: one for the positive, one for the negative, and one for the result, right? Result is nothing but the maximum result and positive, because the question said it should be a non-zero positive product, right? So whenever we encounter zero, like for the elements, let's say for I equals to 0, the elements was 0, right? So here no answer is possible, right? We cannot have this 0 in our possible subarray. So I will just say the possible subarray would be 0 for the positive and the negative, right? And similarly, the result will be 0. Now, when I equals to 1, I'm considering just this element, that is 1. That is 1, right? And if you see, if you just manually try to say that what is the uh, length of the in this current subarray, the length in the product should be positive. So I can say let's take the element 1, right? And the length should be 1. And the negative, since there is no negative element, so the length will be 0, right? Now for I equals to 2, the next element is -2, and I can see that the array elements which I'm processing at the 1 and comma -2, right? So what is the length of the sub array? The longest length in this current sub array, in which we can say that the product is positive. So I can just take the elements, that is 1, and the length will also be 1. But for 2, I can take the both two elements, and I will say that the product will be negative, and this is the maximum possibility, right? Similarly, for 1, -2, and -3 for the next elements, I can take both all the three elements, 1, -2, and -3, and the length will be 3. And for the product to be negative, I can even I can either take 1 comma -2, or I can either take 1 comma -3, but the length would be 2, right? I'm just dry running it manually for you, and then we will think in the code perspective how do we have to configure it, right? Similarly, for the last element, that is 1, -2, -3, and -4, you can see that the maximum possibility we can take is 1, -2, and -3, right? Or either you choose any two negative numbers in these three negative numbers, and you will have the result as positive. So the maximum length for this current sub array where the product is positive is 3, and the maximum length in this current sub array for the product to be negative, we can take all the elements, -2, -3, and -4. If you multiply it, you will get the overall production as the in negative, right? And at last we just, and in every step we have to store the maximum of what is the positive saying, what is the length of the current sub array which has the positive product. So I have maintained that result variable for each and every step, and then last you will get the 3 as answer, and that is 3 that should be returned, right? So what I'm doing is that if I am getting here, if I am getting let's say for this thing, what should be the code here, right? Let me take this thing to another paint, and then we'll explain. Or maybe I highly encourage you to, if you have saw this dry run, then I highly encourage you to write the code yourself, and then we will see that our code matches or not. Okay, so let's resume again. So for this thing, where I said for I equals to 0, what I did that I reinitialized my positive and negative to 0. So for the first case, I am seeing that I can write that if my array of I is pointing to 0, then I can say that positive is equals to negative, or I make it 0, right? And only the rest two cases remains, that is for else if that array of I is greater than 0, and there is one other case, that is, let's say, else, where array of I is less than 0, right? So for the array of I which is greater than 0, I can say that since it is greater than 0, then directly do positive plus equals to 1, right? So let's say we have this thing as 1. Let's say we have this current sub array as -2, right? And the next element to come is positive, let's say 3, right? And for this thing, the positive and negative will points to, the positive is 1, and for this thing, for this just sub array, and the negative will be -2. So if the coming element is positive, that is 3, then I can say that obviously the positive was initially 1, right? So I can just include this number in my previous answer, and I can say that my new possible sub array would be 1 comma 3. So I'm doing nothing but positive plus equals to 1, and it is pointing to 2 now, right? But what about the negative thing, negative array? Will it be affected? I guess yes. So let's say if negative was not equals to 0, right? Negative was not equals to 0, and it was pointing to 2, and the array which it was pointing was 1 and -2, and you itself consider it, you will also agree with me that it is, this product is giving negative because it has odd number of negative elements, number of negative elements. And if we multiply the odd number of negative elements with one positive element, then the overall production will also be negative, right? And that is we want for this negative to have store, right? So that means that you have to consider the previous negative value, that is 2, that was actually pointing to the subarray, that is 1 comma -2, and you have to do +1 for this new incoming element, that is 3, right? This is the new incoming element, and then your subarray will look like 1 comma -2 comma -3. I hope you are getting this point. because this was a very crucial point. When we add a positive element, how the things are changing, right? So I can say here that if the previous negative states is not equals to 0, then what you do, that you do negative plus equals to 1. And that is why this problem belongs to the dynamic programming, because last time someone asked me, the question was almost same, that we are using the previous state, so why dp, why are you consider this problem in dp? Because for a new state to get calculated, we are using the values from the previous states, right? The previous ith index. So that is why. Okay, so let us move ahead with this thing now. So okay, so let us see. So the elements was here 1 and minus 2, and whenever the next negative element came, that is minus 3, the value changes to 3 and 2, right? So let us deep dive into it, that how in the coding structure we can do this. So the elements were, let me write the elements. Let me write the elements for you. It was 1 and minus 2. And this particular subarray says that the positive is belonging to 1, considering the subarray 1, and the negative is nothing but the length of the this current subarray having the negative length, having the negative product. So you can take the both the element here, 1 and minus 2, and the negative is pointing to 2. So with this, what is having the next incoming element is there, and the next incoming element is minus 3 in our case, right? It was minus 3, right? Yes, it was minus 3. Okay, so what should we do here so that our resultant will convert into which thing? 3 and 2. Resultant positive converts to 3 and negative converts to 2, right? So let us see. And it is very obvious that if you have these elements, if you have these elements 1 comma minus 2 comma minus 3, then obviously you can see that the positive sub the array, the length of the in this current sub array, which will have the positive product, is you can do the maximum as you can do the both the negative elements, which will say as the length as 2, and for the negative you can take all the three elements, right? No, for the negative you cannot take all the three elements. You can either take plus 1 and minus 2, or you can either take plus 1, or let me write it like this. You can either take 1 or minus 3, which I explained to you in the dry run, and you will have this thing as 2. And in the positive, you can take all the three elements, right? 1 comma minus 2 minus comma 3, so it will be 3, right? My mistake. Okay, how to tell this thing in my code? So what is happening here is, let's see what is happening here is, we have this element as 1 and minus 2. And what is the incoming thing? The incoming thing is mm, let me write it here. 1 comma minus 2. It is saying that you have this thing as positive equals to 1, and the incoming thing is minus 3, right? Okay, so I'm saying that if another element comes that is negative, right, which is minus 3, then what can I do is, for this negative thing, I can say that this was what? This was what? Hmm. So this was having the negative product because it has the odd number of negative elements, right? And if the next element is also coming as negative, then what we can do is that we can just use the positive numbers here, right? The positive elements here, the 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 sub array which is contributing to the length of the positive product. So I can just copy paste it here. Let's say 1, right? I will just copy paste it here 1, and I will say, since the number is now negative, just increase it by 1, right? So the final answer would be as negative equals to 2, and you see that it matches with this number, right? So the entire logic here is that you have this thing, that you have this negative has always the odd number of elements, right? Odd number of negative elements, and that is why its product is negative. That is why its product is negative. So if another elements come corresponding to the I, which is actually negative, right, which is actually negative, then we can just use the pre-processing states, that how many positive elements were there, or what was the length of the maximum sub array which will making the positive product, right? And we can just add one more negative element in that, and we can say now that the negative will be updated to the previous positive plus 1. So I can say it that previous positive plus 1, right? Similarly, when I'm trying to found that how the positive thing changes, right? So the previous negative for this subarray was pointing to 2, right? This is the previous negative, and this is the previous positive, right? So what would be my new positive now, right? The new positive now. I can say that this 1 and minus 2, 1 and minus 2, let me write it again. 1 and minus 2 will have the positive. Hmm. So this negative, previous negative says that I have odd number of negative elements. That is the reason that why this negative, the sub array product is going as negative, right? So if the new number coming is negative, right? And if I multiply with this one more negative number, then the entire result will be positive, right? So that means for the new positive to happen, I have to take help from my previous negative, which has the odd number of elements as negative, that is 2, right? And as you can see, it was actually pointing to 1 comma minus 2, and now there's one more negative number coming in, that is minus 3, right? And if I multiply the odd number of negative elements with one more negative element, the resultant will be positive. I hope you are getting this point, and the resultant number should be positive. So for the current number which comes in play, I have to do plus 1 for that, that is 3. So I'm doing nothing but the previous negative plus 1. That is the thing I'm doing, right? So that means that if, okay, so in the code what we can write is that I'm swapping the two variables, right? So in if I calculating the positive, I'm using the pre-negative values, right? So I will just write it here that I am swapping it. So I swapped it and I swapped it, right? And since that was a negative value, right? Since that was a negative value, so I did as 1 plus 1, 2, and 2 plus 1, 3, right? That is it. And you can see that my negative is pointing to 2 and my positive is pointing to 3, right? So just understand this dry run. If you're not able to, I highly encourage you to just resume back a bit and understand this dry run, right? So it will be like very easier to write the code for you. So what will be the pseudo code then? So what would be the pseudo code then? So for array of I less than 0, I can say that swap the values, swap let's say positive and negative, right? And what you have to do, that you have to do negative is equals to pre-negative plus 1, right? So I will say negative plus equals to 1, and you have to check that if positive is not equals to 0. If it is not equals to 0, then you have to do positive plus equals to 1. Why I'm checking positive not equals to 0? Because there should be any number left, right? You cannot add a number, and you cannot add one more integer if positive is 0. Positive is 0 in the sense you do not have any numbers in your possible subarray which has the positive product as positive, right? This is an empty subarray. If it is 0, then this is an empty subarray, right? So that is it, I guess. That is it for the coding section, right? Right. So let us code this thing, and I hope you were able to get through this logic. Also, if I just quickly show you the dry run of the second code as well, second dry run as well for this thing which is written. So the elements were minus 1, minus 2, 0, 1, 2, 1, 2, right? The second test case. So for I equals to 0, I can say the positive, the negative, the result, right? So for I equals to 0, it is minus 1, right? So whenever it's a negative value, then what we do, whenever it's a negative value, then we swap the positive and negative. So the initially it is pointing to 0. If we swap it, nothing will happen. And you have to do negative plus 1. So it will be negative plus 1. And since positive is pointing to 0, you do not have to do plus 1, right? So that's where this case comes in play. This check comes in play. If positive is not equals to 0, right? Then resultant will be the maximum of the resultant pointing to 0, 0 comma the positive, that is 0, so it will be 0, right? So for I equals to 1, again there is a negative number, that is minus 2. We will again swap it. So by swapping it, it would be 1 coming here and 0 going there, so it will be 1 and 0, and I will be adding plus 1 here, so it will be 2, and I will adding plus 1, so it will be 1. So now it should be like 2, right? And if you talk in terms of arrays also, So while I was I equals to 1, I was just considering the element, or I just write me here. I was just considering the element minus 1 for I equals yes, so for I equals to 1, I was considering the element minus 1 comma minus 2, right? And as you can see, the possible length, the maximum length for this current subarray to be positive would be 2, and for the negative, as you can just take minus 1 or minus 2 for this negative thing, right? So for I equals to 2, you can see for I equals to 2, again it's 0, right? So you have to update the possible and negative at 0. So you are not considering any array here, and the resultant will still be updated at 0. So this is one of my possible answer, right? This is one of my possible answer. Let's get back to the I equals to 3, and you have this as positive element. So you will do positive increment by 1 and nothing in the negative, because it's actually pointing to 0. So it will again be 2. And for I equals to 4, the last iteration, that is pointing. So at this I equals to 3, I was pointing about this array 1, and I equals to 4, I'm talking about this array 1 and 2, right? You will again doing the plus 1, since this is a positive element, and you do not have to do anything in negative, because that is like already 0. So I will say 0, and it will again be pointing to 2. So these are the two possibilities that our answer is coming as 2, 2 and 2, right? So I hope you were able to get through this dry run as well. So now let's just implement the code, right? So I've already written the skeleton of the code. That is the all the three cases where we actually need to implement our logic, and the initialization of the variables, just to save us the time, right? So if the element is 0, then we need to reset the positive and negative. Reset the pos and neg. And I have declared what is POS and any NEG, right? Okay, so it will be pos equals to negative is equals to 0, right? So now if it is greater than 0, then what we need to do, we need to first implement increase the positive element as 1, because we have got the first element as positive. So it means that it obviously says that the length of SA, or let's say positive SA product, increased by 1, right? Right? So let me write this thing as comment here. And simultaneously, I have to check that if negative is not equals to 0, then I have to do negative plus equals to 1. That is it, right? So if I just write a quick example for you. So let's say the elements were minus 1 and minus 2, and the new element which is coming is 3. Okay. So for this minus 1 and minus 2, the positive, let's say the new element coming was 3, right? So what would be the change in the positive? So the positive will change from 1 to 2, right? And similarly, this negative will change from 2 to 3, right? Why 2? Because it was considering the possibility of minus 1 and 2 with the length as 2, right? And since this was the uh, it should have the odd number of negative integers, so we just have to do plus 1, right? Okay. Okay, so in the else part, we need to first swap it, right? So I will say int t is equals to, let's say, positive, and then I will say positive is equals to negative, then I will say negative is equals to t, right? And what I need to do, that positive plus equals to, or let's say it was negative, right? So it will be negative plus equals to 1, that is for sure, right? Okay, plus equals to 1, and I simultaneously have to check that if my positive, right, which is actually pointing to the previous negative, right? So if it is not equals to 0, right, then I have to do it plus 1 too. So positive plus equals to 1, right? So as you can see, so it may be a little difficult for you to digest this else part, but always come back to the test cases, right? Always come back to the dry run we made, and it will be like very easy for you to accept it. So this is the dry run we made. We already proved that how is it coming there, and we try to code it in this perspective, in the coding perspective, right? So we swap the variables and we do plus 1, right? Since this was a negative, so it is positive is negative is nothing but pre-positive plus 1, as you can see here, and negative is positive is nothing but pre-negative plus 1, right? So we just swapped the variables and we did plus 1. That is it, we did it, right? Okay, so that is it, I guess. And I think we'll be able to run this code now. So for each and every else if, we have to return the maximum, right? So I will say that or not return, let's say update it. So result is equals to math dot max result comma positive, right? And the same thing will happen for the else case as well. I will write it here as well. So that is it. So let's compile and run and we see for ourselves. Now I missed the semicolon here. So let's write it and compile and run again. So your output and expected output matches. And since the time complexity of this code is O of n and space complexity as O of 1, because we are nothing using but a for loop here. So this code should get submitted. So let's wait for the results. Okay, so let us see. Something is wrong here. So yes, it is running fine. The same code submitted successfully. And okay, so that is it for today's video. And let me write some comment here as well so that you can get a more clear understanding for this. So let me write the comments as well and then we'll end this video. So I've added some comments as well. Let me explain you that. It will give you a clear understanding as of now. So else part, if the, so there are two possibility, right? So when the negative element comes, what was the value of the previous negative and the previous positive? So the previous negative has always, it is negative. The product is negative because the it it would be having the odd number of negative elements. That's why the product is negative, right? So if the next negative element came, and if I multiply a negative number to a bunch of odd number of negative numbers, the product will be positive, right? So that is why I swapped the variable. I calculated, I first swapped the negative answer into my positive and I just did +1, right? Similarly, for the positive thing, it must have the positive number of elements as well as maybe the even number of negative elements, right? Or no negative element. That's why the product was coming positive, right? So if the next negative element came, so I can just multiply this negative elements to the bunch of the positive product, and we can get one big sub array with a with a negative product, right? So that is why for this positive thing, we we stored the previous positive into my negative, and that is why this swapping is happening, right? In the negative we are storing the previous positive, and in the positive we are storing the previous negative, and we are just doing the increment +1. That is it. So I have given a walkthrough also for this else part. Else if remains the same, this is the condition here, you can see that. And for I equals to 0, we are just resetting the values, as well as these three variables are pretty clear to me. So let's end this video again when we will get back tomorrow in day 110, I guess. So you last thing, that's my DSL repository. You can start and fork to get help with the source code, as well as that's my Instagram channel. You can connect me here as well as on my LinkedIn for any doubts or guidance that we may have. And you still have doubts regarding this question, and I don't think you will have reading these comments as well as the dry run going through again and again. So, but still, if you have, you can ask me in the comment section. And till then, keep studying, keep growing, and take care.